Okay, this is Dr. Polig, and we are now looking at page 421, Geometric Optics, Module 12, and we're going to look at question 5 and question 6. We're going to look at these together because these questions are actually are virtually the same, and so we're going to look at both of them. Okay, here's a window. And right now we're going to imagine that the window is just a simple, very thin window like this. This is the window. This is outside. And this is inside. And this is you. And you're looking out the window. Okay. If it's daylight, it's daylight. You know, the daylight is coming through from the outside, and it comes through the window, and you can see it as you normally see anything out a window. Okay, now in reality, we know that when a ray of light comes in and hits a glass, it 96 roughly 96% will be transmitted through. About 4% will be reflected back. And just as a side note, if this is air and this is glass, and now I'm expanding the window to be really wide just for the effect. If the ray of light is coming from the outside here, there's 96% gets transmitted through, 4% gets reflected back. The same thing happens as it travels from the glass into the air. Okay, 96% of the ray of the energy in the glass will be transmitted and 4% back. So really this 4% reflection will happen on the front surface and the back surface. We're going to, for the purposes of the window we're talking about up here, just imagine that it's just it's a thin window, and we only see one of these reflections back, just to keep it simple. But in reality, you do get a reflection back on the front surface and the back surface also. Now, so this explains why you can see the outside light, because the light gets transmitted. Most of the light will be transmitted through the windows to where you can see. But you're in a well-lit room, and so there's light scattering off you in all directions. Some of the light scattering from you hits the window and transmits through. Again, 96% gets reflected through. But 4% of light from the inside gets reflected back to you. And if you focus on the 4%, or if it's not daylight, say it's nighttime, then this 4% that gets reflected back to you is going to be much brighter than what's coming from the darkness. And so in that case, the window appears like a mirror. Does that make sense? I hope so. That if this 4% that gets reflected back to you, if that's brighter than what's traveling through the window to you, then your eye will tend to focus more on that, and you will perceive the window to be in fact, a mirror. Okay, that links up to question number 6, where you have this interesting effect that you have in a church where you have imagine this is a child here, and this is bright. So the children's nursery is bright over here, and over on the other side is not outside, but it's a dark or relatively dark hallway where the parent is. So notice that in this case, the child, the reflection off the window from the child is 4%. That 4% is much brighter than what gets transmitted through. If this is a parent's over here, the parent is looking at the child. The 96% that gets transmitted through the window can easily be seen by the parent. But since the hallway is dark, the light from the parent that gets transmitted through the window is much dimmer than the 4% that gets reflected back. So in that case, the child, when sees the 4%, this looks like a mirror to the child. Does that make sense? And so the parent can easily see the child, but the child cannot see the parent. Now, if the child is smart, the child goes up close, puts his face right on the window, and it blocks, and you use your hands to block out the bright light from inside the room, then you can easily see right through the window. Because then the dim light that's transmitted through is what your eyes can focus on. So I hope that makes sense. That's questions 5 and 6 on page 421.